You are listening to the Drafting and Architectural Techniques lecture as part of the Fundamentals of Construction Management course. Here are some quick instructions for this video module. Use the buttons at the bottom of the video to navigate the module, pause it, go back, or control volume. You will often take an assessment after each video. For all assessments, please go to the Quiz tab in Canvas. For any questions about this content, please consult with the instructor at apmccoy@vt.edu or use the discussion section of the Canvas website. Here are the learning objectives for this module. By the end of the module, a learner should be able to identify the 5 influences on architecture, identify ways that architecture communicates a process, define single and multi-view drawings, identify the stakeholders of the architectural process, and explain the role of a contractor as a stakeholder in the architectural process. To begin, I'd like to pose the question to you: what is architecture? Some have called it, like William Morris, the molding and altering to human needs of the very face of the earth itself, which is quite grand. Mies van der Rohe, a famous architect, he called it the will of an epic translated into space. Well, others look at it as the art and science of designing structures. For a building, for example, it's about creating order, people ordering the environment for the benefit of other people. It's a concept or an idea often. It uses the medium of building, and it communicates a process, which is very important. But then the question could be, how does it communicate the process? I like to show often students a blank piece of paper, because if you really think about it, this is the way that a building starts. Architects typically start with nothing. They start with a vision, an idea in their head, and they have to use a blank piece of paper to try to communicate that to all the different parties involved and do it in a way that is successful and that tries to make sure that there is a successful project. It's a very important process, and it starts with very little, and then it becomes something that you see built in the environment. So what is construction then? Well, I think it is the business of architecture. Often you have an architect who's taking a blank piece of paper, turning it into a vision, trying to communicate that vision well, working with an owner to make sure that the vision is what the owner is hoping to have, and then translating it into a form that the builder or the constructor can turn into a real building with a real asset. In many ways, that's what the constructor is meant to do. The constructor is meant to understand all the different sides of the business that allow for that vision to become a successful project. That could be risk reduction, that could be management, and that can be all kinds of different aspects that we'll talk about later in this lecture. So what are the different influences on architecture that in turn become something that we need to consider in construction? Well, there are 5 that I'm going to list here. One is the needs of the building, right? Obviously, we have shelter as a need and something that is important that we need to incorporate into the building itself. Increasingly, shelter and the way that that works in building science is becoming important. We'll talk about that with climate later down this list. Society is an important side and influence of architecture. You have government buildings, monuments, different buildings that you might try to build in your career that reflect the needs of a society. We have a lot of technology that influences architecture, especially today. We're building faster, we're building cheaper, we're building more durably, but at the same time, you might leave school and go work in a server farm, building one of these large server farms for a company like Facebook. We have culture that influences architecture. We have local traditions, local trades. At Virginia Tech, for example, we have a lot of buildings built out of Hokie stone. Well, this is a trade that has really grown in this area and that you can see all around the Virginia Tech campus. And then we have climate. You really need to understand as a constructor how shelter deals with its environment. And this is something that influences the architecture as well and that you're going to have to work with in your career. So if we have many different influences on architecture and goals of the vision and communicating that process, how does architecture actually communicate that process? Well, there are some specific views that architectural drawings typically try to establish so that they can communicate different ways, different types of information that builders can put into place. One is a multi-view. It's the drawing of one static side or view of the building. That means typically that the multi-view requires many different drawings so that it can communicate everything that the builder needs to know about the building. So we have plans, we have elevations, we have sections, we have detailed drawings, we have many different drawings, and this would be the typical set of drawings that you would expect to see, but they're called a multi-view drawing. And then, not to be too confusing, but we have what we call a single view, where we've been able to simultaneously communicate more than one side of an object in the same view. So a single view drawing actually incorporates all types of different views of the building, like a perspective or like a paraline, we call it, which are axonometrics, so that we can look at the building from multiple angles and get more information than just a flat two-dimensional plane, which is what the multi-view represents in plans and elevations. So building off of what we previously discussed regarding multi-view and single-view drawings and the idea of how architecture communicates a process, this slide shows an example of multi-view drawings. In this case, what we're seeing is an elevation, we're seeing a plan view from above, we're seeing a section view as well cutting through the building on the bottom right of the slide. These are the most common types of drawings that you're going to see in your career, but increasingly as we work with building information modeling, we will be able to communicate a lot of information in one drawing that is not a multi-view, but it actually is three-dimensional. You have multiple views of different planes within one drawing. It's important to note with the multi-view drawings that no single multi-view drawing can communicate the true configuration of the object that you're going to be building, which will be three-dimensional. What we typically call the multi-view an orthographic drawing, which means that basically each of the drawings are perpendicular to the edge of the paper. So if you imagine a drafting board, then the drawings start by using the edge of the drafting board as the beginning of the way that you will draw parallel lines on the page or perpendicular lines to the edge of the page. And here's an example of a single view. It's much less common, but as you can see here, and this would be an axonometric, so that if you look at the edge of the page, each angle is somewhere around 60 degrees or 45 degrees from an angle of the edge of the page. But in this case, we're seeing that we can simultaneously communicate more than one side of the house here, or the object on the paper, by being able to have a drawing that looks at multiple sides in one single view of the building. Increasingly, as I mentioned before, building information modeling allows us to use a single view projection for a building and understand a lot of information about it, even zoom in and get into the details of the building and the interior of the building, things like that help us really be able to build the building in the computer or on the paper before it ever gets actually put into place. And here's another example of a single view projection. In this case, it's a perspective drawing. It takes the idea of being out on the street in front of this home and looking at it, and it takes the level of view plane from someone who might be standing out in front of the building, and then projects the drawing so that you can see multiple planes of the building, you can see multiple sides of the building, and you can understand a lot more about how it's going to look once it's actually built in place. And as I mentioned before, building information modeling is something that allows us to do this increasingly in a fashion where we understand exactly how to build it by being able to look at the building from the perspective of being on the ground or at different levels, and all of the different techniques we're going to need to use at those levels so that we can work with the building and reduce risk, create a safe environment, but also have good production and understand all of the different aspects and the difficulties in producing the building. Okay, so to recap, we've talked about the difficulty in being able to take a blank piece of paper, establish a vision, work with an owner, work with a contractor, and turn what is a blank piece of paper into a real project. And the process of communicating that project through different types of drawings, a multi-view which has single images and planes in two-dimensional information, typically like plans, elevations, sections, or a single view which has multiple planes on it and is able to communicate in one single view a lot of the information about the building. But now we need to think about really who cares how architecture communicates a process. Well, I would say that there are a lot of people who care. All of the stakeholders of the process do. The more information, the better the information that is on a piece of paper that you can use as a contractor to build a building, the better off you are. And you're going to constantly be working with architects and designers in a way that hopefully will provide better and better levels of information. But here's a quick list, and the list keeps going, but the clients are important stakeholders and they care a lot about the level of communication in a drawing. Engineers, general contractors, subcontractors, manufacturers, suppliers, distributors, retailers, inspectors, all of these different stakeholders and more really rely on the communication process working from that blank piece of paper until we get a building built. And it's going to be important as a general contractor or as a contractor or even a subcontractor, whatever your role might be, that you are engaging in that communication process and working with the designers to make sure there's as much information as possible to build a quality, affordable, excellent building. So now that we've established who cares, what would be the contractor's role as one of those stakeholders? Well, one important role is that you understand what is trying to be communicated by the architect. You understand the vision, you understand the goals. When I used to work as a contractor, I would work directly with architects to find out typically what kind of details they liked in their buildings. Did they expect items to line up when it comes to trim and door headers and window headers, which is very typical, but things that architects really pay attention to that you need to understand really well as a contractor and work with all architects to make sure that that information is clear on the drawings. You're going to have to translate a lot as a contractor. You're going to be assuring quality, you're going to be dealing with safety issues, means and methods that lead to safety, the schedule and the cost. These are all tools that you're going to use to communicate and that we'll learn in this course. But also they're important that you're using them in a way that can help the designer understand early on what are the expectations of the project from the construction side. And then you need to be able to communicate well, partially to limit and spread your liability. If you can do a good job of documenting and communicating, often that does limit your liability. But also it's going to help with the project itself and the product. It's going to improve durability. It's going to increase your profit. It's going to make the schedule work much better. It's going to ensure safety. It's important that everyone who shows up for work is able to go home that night. And then increasingly and more recently, the sustainability of the building and understanding ways to be more effective when it comes to sustainability and through technology. Increasingly, technology is becoming important when it comes to building. So here I'm showing you again the perspective of the builder there in the bottom right, labeled D, and how that single view of the perspective of the house turns into these multi-view two-dimensional planes that we use as drawings. And that's kind of the process of how we take a vision and we put it on paper, and we are standing as contractors trying to make sense of that and then communicate it well with the designers, working with them to make sure that that vision comes to a reality the way that they're hoping and the way that the client is hoping especially. And you might be surprised to know that there are many ways that a drawing communicates. It's not just the view, which we just talked about through multi-view or single view types of drawings, but drawings communicate through the lines on the drawing, different types of lines, different thicknesses of the lines, the scale of the drawing itself. When we have a scale that gets really into depth, we're starting to see what happens behind the walls now and the details versus a scale that's not really in high levels of depth and it's much more of a plan view or even a site level view. There are lots of notes on drawings that are important for us as contractors to be able to read and understand, and it's an important form of communication on the drawings. You don't want to skip those or miss those. We have schedules, which look like tables. These are not to be confused with the building construction schedule, but more what we call a schedule of windows or doors that lists all the different doors, the finishes on them, the size of them, the rough openings on them, things like that in the drawings. And they're typically represented in the drawings by a table. Drawings also communicate quantities through dimensions and counts of objects. So we might have a count of windows, for example, that the drawings communicate, or a count of steel in the footings, which we call rebar. We've talked about ways that a drawing communicates. In this slide, we're seeing communication through lines. For example, the width of a line can give us a better idea of the detail that the architect is trying to communicate, or it can affect the ability to reproduce the drawing. If you have very thin lines that are hard to read and you try to reproduce the drawing, often they don't come through. So you need to have thicker lines that can be reproduced multiple times. At the top of this slide, what you see is a scale all the way from the softest type of drawing pencils, which have more graphite, a 6B, to the hardest type of drawing, which has more clay in it. A hard drawing line is difficult to reproduce. A soft drawing line becomes thicker on the page, and that's why they put more graphite in it, for example. Often what you'll see is architectural drafting uses anywhere from right in the middle of this scale, from an F to a 4H, 4H being the hard, or if you're going to be doing renderings and different colorings of the drawings, you'd start with the opposite direction to the left, start with an HB and go down to 4B, being some of the softest leads that you might use. I'm giving you an example here at the lower part of the slide to show you how lines are used. If you look at the outline of the door itself, the outline is very strong and very thick as far as a line goes. But once you start getting into the detail of the raised panels of the doors, well, we start seeing that there's dotted lines or that there's thinner lines to suggest certain shapes, but they're also showing you a depth to the line so that you can see that there's some parts of that door that are behind other parts of the door. And then we have dimensions as well. 6'8" is the dimension on of the vertical part of the door, and that is written in a thinner line as well, not to be confused with the outline of the door itself. On the right side of the slide here, I'm showing you some different ways that lines are used on the drawings. You can have hidden lines which become dotted, which is number 4 there. Often that's a medium thickness to it. Hidden lines typically would suggest for example, an opening in the floor above you. And continuing with ways that a drawing communicates, we mentioned scale before. Often the drawing will show a scale, and that's how you know the size of the different items on the page. Well, when do you use the scale? You always go from listed dimensions on the drawings before using your architectural scale to scale out the dimensions on the page. So if you have a choice of looking at dimensions or taking your architectural scale and trying to go exactly from that scale, always go from the dimensions first. But at the same time, size does matter. The larger the scale, the more detail and information that you're going to have on the page. On this slide, the architectural scales to the right that are grayed, if you go to the very bottom, that would be the largest scale that we have in this table. That is 3 inches to 1 foot. And the way you think about the scale factor there, which is 4, is if you had 12 inches to 1 foot and then you were reducing that scale down to 3 inches equals 1 foot. And part of the reason why you do that is because you can't draw a building 1-to-1 and fit it on a piece of paper. So if you go to 1/4 the size of 12 inches equals 1 foot, which would be 3 inches equals 1 foot, then you're basically taking a scale factor of 4, or basically dividing 12 inches equals 1 foot by 4. And it's the same as you move down. They'll take, often drawings will have the 3 inches equals 1 foot reduced down to 1.5 inches equals 1 foot, going all the way down to quarter inch scale, where 1/4 inch equals 1 foot, where you have a 48th of the size of the actual object that you might be looking at in person. You're drawing it on the page so you can fit it onto a page. This is a great reference for you to use moving forward as far as the drawing scale and then the size of that scale in the drawing that's being represented on the paper. Also, I've listed here under C some YouTube video resources. These are great videos to go look at how architects use their scale, and then also some engineering scale examples as well. So please go look at those videos as well as part of this lecture. And continuing with the theme of ways that a drawing communicates, sometimes drawings will actually spell out a notes section, and that's what I've highlighted with the red circle, dotted circle in the lower left of this slide. The architect here is specifically stating certain parts of the drawing that they want to communicate through written text, and there's a note that tells you exactly what the architect is thinking. Or if you go to the top left, I've used the dotted red ellipse there to show you an example of where text is used on the drawings to specifically talk about, in this case, a rod that is holding the chimney or stabilizing the chimney on the left side of this building, and making sure that it doesn't collapse out away from the building. Schedules are another way that drawings communicate. I mentioned them before. I talked about them a little bit. Here's an example. When I discussed them before, I said that they would be in a tabular format or a table. In this case, we're talking about finish schedules or equipment schedules as well. Before I talked about window and door schedules. Under finishes, we see room numbers. We see the designation of the area, what type of floor you're going to have in that room. Is there a wall base material? Is it a 4-inch vinyl strip, for example? And then in that room, what the wall finishes might be on the north wall, the south wall, the east wall. Just examples of finishes for rooms in a building that as a typical schedule. Also, we have the same list of schedule items with equipment, where we need to quickly communicate a lot of information that is in detail about exactly what is expected based on the room or the type of equipment and the needs for the system. These are typical schedule types you might see on drawings. Moving forward then with the ways that drawings communicate, we also will see quantities. Like I mentioned before, I talked about footing, re-steel, or rebar. Well, sometimes we'll have a schedule combined with drawings that designate certain types of footings. In this case, I've highlighted the C8 concrete column, or I guess it would be, a steel column, but there's a footing underneath it that needs to be built first. And so we're seeing on the right the structural drawings where the concrete footing would be poured. And we see the designation of the concrete footing being an F9.0, that is paired with a column C8 above it. And so we know exactly how many different pieces of resteel need to go into those footings, every type of footing that is an F 9.0. But we also see, because often our role in this is to place anchor bolts for the columns, we see the anchor rod designation above that needs to go into place so that the steel fabricator and erector can put the steel column in place. This concludes the Drafting and Architectural Techniques lecture. The learning objectives of this lecture have been to identify 5 influences on architecture, identify ways that architecture communicates a process, define single and multi-view drawings, identify the stakeholders of the architectural process, and explain the role of a contractor as a stakeholder in the architectural process.